I'm going to try to explain the basics of matrices. If that's what you want to learn, obviously it is, that's why you're watching this video. If you've done graph transformations before, you'll recognize this as a vector. Well, a vector is a 2x1 matrix. Here's another example of a matrix. It's a 3x2 matrix. The dimensions of a matrix are the number of rows by the number of columns. So see, there's 3 rows and 2 columns, so it's a 3x2 matrix. To put it simply, a matrix is a box of numbers. This is a matrix and this is an element. Adding and subtracting matrices is pretty simple. When you add two matrices, when you add these two matrices, you get this. All you have to do is add the corresponding elements, like so. See, the first row and first column of each matrix added together results in the first row and first column of the resulting matrix rather. Subtracting is exactly the same process, except with subtracting instead of adding. Multiplying a matrix by a number or scalar is also pretty simple. You just have to multiply each element by each of the numbers. Each element by the scalar. Multiplying two matrices together is a little bit more complicated. You can't multiply any two matrices together. For example, this is a 2x1 matrix and this is a 2x2 matrix. To be able to multiply two matrices together, these two numbers must be the same. The first matrix has the same number of columns as the second matrix has rows. So in this example, we can't multiply. However, if we swap the two matrices, they can now be multiplied. As you are about to see, the resulting matrix will have the same number of rows as the first matrix and the same number of columns as the second. So the result, when you multiply these two matrices together, is this, a 2x1 matrix. To get the result, you have to multiply each row of the first matrix by each column of the second matrix. It may be easier to think of it as the first row times the first column is the element in the first row and the first column, and the second row multiplied by the first column is the element in the second row and first column of the result, and so on. Here's another example. This is a 2x3 matrix. If you multiply it by this 3x2 matrix, it equals this 2x2 matrix. So you see the first row, if you take some time to get some note paper or something, you work out 2 times minus 1 plus minus 1 times 2 plus 1 times 4 is 0. It's minus 2 plus 4 is 0. This is a 2x2 identity matrix, and this is a 3x3 identity matrix. Identity matrices can be any size as long as they are square. They are the matrix equivalent of 1, so if you multiply it by any matrix, one of these by any matrix, because it depends on which matrix, because you can't multiply any matrices together, you'll get the same matrix as you multiplied it by. So I hope this video helped, and good luck.